Finding area in everyday shapes is more common than you might think. Today we're going to look at examples in furniture, landscaping, and also home improvement. One of the first examples we're going to look at involves furniture. I purchased an area rug for my living room. How much room will it take up? You don't want to purchase a rug for a living room that's too small, because then it's not enough of a statement piece, but you also don't want it to take up the whole room because then it's really overpowering. So what if we want to figure this out? If we look at the top of the rug, usually rugs are in the shape of a rectangle, and most rugs are 5 by 7s. So we're going to label the height of this rug 7 feet, and the base, or the width of this rug, is going to be 5 feet. To be able to calculate the area of this rug, we need to use the area of a rectangle formula, which is base times height. So if we plug in our base of 5 feet and our height of 7 feet, we can multiply those numbers to see it'll take up 35 square feet of space. Another example we might come across is, what if I have a backyard and I'm trying to reseed it? It needs grass seed. It's in the shape of a triangle and I'm unsure how much grass seed to buy. You don't want to get halfway through a job like this in your backyard and realize that you need another bag of grass seed. That's not a good way to start out your spring or your summer. So let's take a look at the shape of this as a triangle. My metaphorical backyard is going to be a little bit tinier than you might be used to. So we're going to say the height of this triangle is 15 feet, and the width of this triangle, or the base, is 10 feet. Well, we're actually going to find the area of this triangle using the formula for the area of a rectangle, which, remember, was base times height. The reason we're going to use that is if you take a triangle and copy it on itself, where you see these dotted lines appearing, it makes the shape of a rectangle. So we change the formula to be base times height divided by 2. So now that we know the formula for the area of a triangle, which is that base times height but cut in half because it's like half a rectangle, we can plug in our base and height and calculate the area. And then in this case, if we use all our calculations, we get 75 square feet. Okay, so the area was 75 square feet. I still don't know how much grass seed to buy at the store. Well, if one bag of grass seed covers 25 square feet of lawn, how many bags should I purchase? We can take the area and divide by how much the grass seed will actually cover, and we get that we need to buy 3 bags of grass seed at the store. Let's look at our final example for home improvement. I need to paint a wall in my house, and it's the shape of a trapezoid. How much paint should I get? You do not want to get through painting a wall and stop halfway and have to go to the store and buy new paint. You might not get the same color, or it might turn out streaky on the walls. So let's look at our trapezoid. The height of my wall, we're going to say, is 12 feet tall. And we're actually going to divide all the other dimensions so that it's a rectangle in the middle and 2 triangles on the edge, because we already know how to find the area of a rectangle and the area of a triangle. So what we're going to do is add those areas together. Don't forget, area of a rectangle was base times height, and the triangle is base times height divided by 2, but we're going to times again by 2 because there were a triangle on each end. And what happens is that times 2 and divide by 2 cancel. So we're just going to do base times height plus base times height. So if we take that formula and plug in the base and height of the rectangle, the middle part of that trapezoid, and the base and height of each of those triangles, we can find our total area, which in this case is 108 square feet. Okay, that seems really complicated though. I kind of wish there was an easier way. How can I have found the area easier? What's the formula for the area of a trapezoid instead of splitting it up into 3 totally different shapes? Well, let's look at that trapezoid in a different way. What if we cut it into 2 triangles instead by drawing this line right across the middle? We have a base and height of triangle 1, and we can use base times height divided by 2. Then I see a base and a height for that second triangle, And again, we can use base times height divided by 2. The reason I'm calling one base 1 and the other base 2 is because they're different bases. They're not the same number. So if we added those together, we should get that same answer. So my thought is, what if we take the height out of both of those guys? Then if we simplify that equation to look a little nicer, we get the equation of a trapezoid we've seen before in our math classes. So area of a trapezoid is base 1 plus base 2 times the height, all divided by 2. Well, we know base 1 is 6. Well, base 2 is 12 feet if we copy that 6 down in the middle and add the 3 plus 6 plus 3. Let's plug in all of our numbers. And again, we get 108 feet squared. So that's nice that we have two different ways of finding the area of a trapezoid. Well, if the area was 108 square feet, one can of paint covers 27 feet squared of wall space. So how many cans of paint should I purchase? Again, let's take the area and divide by how much area each can of paint covers. Lets me know I need 4 cans of paint at the store. So we just used our 3 real-world examples to talk about 3 different formulas for areas. We use furniture for area of a rectangle, landscaping for area of a triangle, and an example in home improvement for the area of a trapezoid. So like I said, finding area in everyday shapes is actually easier than we thought, and it actually comes up more often than we think too. So I have a challenge for you. I challenge you to find the area of these shapes in your everyday life. What about things like a yield sign, a chess table, a slice of pizza, or a birdhouse? Thanks for watching, guys.